Good morning, student. Today in this class we will solve some numericals on resistance, student. As you already know, the resistance of a wire is given by this stands for resistivity, student. This is length of the wire and this is area of cross section. So resistance depends on the resistivity, the material, length and the area. Now suppose we have a question. We have a 4 ohm resistance, 4 ohm resistor, I should say. Resistance is the name of the property and resistor is the name of that device. Okay, student? 4 ohm resistor. The question is 4 ohm resistor is doubled on it. A 4 ohm wire resistance wire is doubled on it. Calculate the new resistance. We have to find out new resistance. Now see, suppose student, if the original length is L, it is written doubled on it. This is the length. So I am making it doubled on it means I am just making it like this. This means this length is becoming the new length, is becoming L upon 2. And when I am making it double, suppose the initial area was A, student, the final area is becoming 2A. Now student, suppose the original resistance, I am denoting it by R. This value is given 4 ohm. So this R is rho L upon A. Now the new resistance, I am denoting it by R1, new resistance. Okay, student? Rho, the material is same. Length has changed, student. Area is also changed. Now, student, L1. This L1 is this L by 2. As I said, doubled on itself. This is L1, student. So this is L upon 2. And this A1. This is A1, student. Final area. So this is twice A. So if I solve it, student, it is becoming 1 by 4 rho L by A. And rho L by A is original resistance R. So this is becoming R by 4 and R value is already given 4 ohm. So 4 by 4. The answer is 1 ohm, student. This means, student, when a wire resistor is doubled on it, the resistance is becoming 1 ohm. How I got it? You understood now, student? The original R is rho L by A. Final R, rho, length has changed, area has changed. But how length has changed? Doubled on itself means length has become half. And area became twice. Area became twice, student. So this is how you have to solve, student, this kind of numericals. One more concept which works on this case is, student, that is the volume of the wire will remain same. Now let's solve, student, another numerical of this kind. We have a piece of wire of resistance 20 ohm. A piece of wire of resistance 20 ohm. Now, student, this wire is stretched This wire has been stressed to twice its original length. Twice its original length. You have to find the value of the new resistance. Find the value of new resistance. Now student, let the original length be L, area of cross section be A, and the resistivity rho. Then student, the resistance, just now we solved it, rho L upon A. This value is given 20 ohm. Now student, the new, it has been stressed. The new length I am denoting it by student L1 and new area by A1. Now as student, the wire is stressed, the volume remains same. Volume is same student. Volume must remain same. So initial volume is A into L, final volume is A1 L1. Okay student. Now it is given that it is stressed to twice its original length. This means this L1 is twice L. So I will substitute here student. AL is equal to A1 into twice L. L gets cancels. So I get the value of A1, A by 2. This is new area student. Now student, the new resistance I am denoting it by R1. Formula will be rho L1 upon A1. L1 student twice L. A1 A by 2. So this becomes student 4 rho L by A. And student 4 rho L by A is original resistance 20 ohm. The new resistance is 80 ohm student. This is the new resistance which is got. So this form you have to remember the concept, volume remains same. Initial volume or and final volume, because the wire is same student. In the similar way student, let's solve another numerical. Suppose we have a wire of copper of length 200 meter, area of cross section 2 square meter, and the resistivity student resistivity, simply I am writing copper C. Okay student. Now this wire has been cut into two equal parts. Okay, the question is, what is the value of new resistance and resistivity of two equal parts? new resistance and the resistivity of two equal parts, student. Now student, this is the wire, suppose copper wire. This original length I am taking it L. Now it has been cut from two equal parts. Now the length becomes L by 2, L by 2. The original area is here, area is remain same, student. Area is remaining same because it has been cut only. Length has changed, student. Now student, both will have same resistance, the same length. Now how much is the resistance, new resistance, student? See. The formula is rho L by A. Rho is rho copper Cu. L, half of this 100. A is same, student. So resistance will become 50 rho Cu. Now student, what is the resistivity? Remember student, resistivity is independent of dimension. Resistivity is independent of dimensions. It depends only on nature of the material. And nature has not changed, it is the same wire is cut, so resistivity remains same. Resistivity remains same, student. Now suppose in the same question, student, these two wires now they are connected in parallel, suppose, student. Now I am making it a resistance. L by 2, L by 2. Okay, student. Now what is the new resistance? Resistivity again will remain same. So what is the new resistance, student? Suppose, student, this is the original resistance, this I am denoting it by R. Then only the length became half and resistance proportional to length, all are quantity are same. So this resistance will be, student, R by 2. Remember it, this. If original was R, then this will be R by 2, R by 2. Now this means I have two resistance in parallel. R by 2 now I have to find out total resistance. So 1 by R equivalent, student. 1 upon R by 2 plus 1 upon R by 2. This is 2 upon R, 4 upon R. So resistance will become R by 4. Means what was the original resistance? You have to divide it by 4. And all the data were given in the question as I told you. Okay, student? The length was given, area was given, and rho was not given. You can directly write rho. So the original one, that you divide by 4. That will be the total resistance when they are combined in parallel. Similarly, you can find out when they are connected in series. In series, student, what will happen? R by 2, R by 2. Now series, you know, it is added. See, student, it is becoming same as the original because now they are added, so it is coming out to be same as the original one. So student, remember one conceptual part. In series, the resistance increases. In series, resistance increases. In parallel, resistance decreases. Why? Because in series length increases, student, and resistance is proportional to length. In parallel, resistance decreases because in parallel area increases and resistance is inversely proportional to area. This is the reason why in parallel resistance decreases, because area increases in parallel case. So resistance is inversely proportional to area. So if this is increasing, resistance will decrease. In series, length increases. Hence resistance will increase. Resistance will increase, student. So remember, student, resistivity will change only with the change of the material. And in this case, we are considering temperature constant. Otherwise, due to temperature, resistivity changes. But in this case, we are studying the cases of constant temperature. So resistivity will not change with the same material. It will only change when the material has been changed. Okay, student, this much for today's class. Thank you.